State Performance Trials. We want to be pushing management. We push management. It's 120 pounds of N. We want all this granular this year. Two splits. They get two fungicide applications. We went with a T1 fungicide and then at flowering as well. So you do see some greenness. There are some benefits to fungicides in terms of extending that grain fill period to greenness, right? And that's just broad plant health benefits. But they do tend to tolerate drought a little bit. Some of those over there, you saw there was some drought stress there. These plants are a little bit more robust in the face of these environmental challenges. So we have about 100 entries, and so in about 30 of those entries are commercially available. And there are a lot of different varieties available in the eastern U.S. It's fast-moving water, where varieties will change out fairly quickly within a company, and so it's good to check out what's new. You know, ask those sales reps, what do you have that's new? What do you have that has the traits that you're interested in, right? And so for here, it's going to be Fusarium headband, of course, yield potential, straw production, right? Other parts of the world, it might be barley yellow dwarf, it might be leaf rust further south, right? So these companies know all about these. Varieties are very different in terms of their performance and those traits that they have. And so one of the goals, like with Dr. Singh's study, we're trying to match up those variety characteristics with the management practices. Just like with Fusarium headblend, you know, we're matching and splitting maturities with varieties. You're trying to match those varieties to your workflow. And so, like the canopy, so you can see that you'll see all those different canopy architectures. This would be a more upright plant architecture here, versus you can see these tillers are occupying these rows. I don't know exactly what variety that is, but you can see the differences here. This is whitetail. Heck, this might be whitetail right here. So we see this has a relatively upright plant architecture. Yeah. But it's Marlin. Or Marlin. That was my second choice, actually.
We can tell you on this side.
Oh, okay, fair enough. Yeah. Fair enough. There we go. Here we're marked. Okay, so this is outstanding. Yeah, so we can talk through some of these. There are a lot of different varieties available. Now, I'm not going to talk about any of the company varieties. But we do have folks from these companies aren't present here. Just look for the name badge. So, yeah, Marlin's been pretty consistent, good performer for quite a while. But you can see we have, on versus onless, and some of that is aesthetics and preference. But they do have a range in yield potential. They do have a range in head scab resistance as well. And so if you're looking for a straw producer, right, you can kind of get a visual image with those varieties that you see the names in the reports. So you got straw producers here. Definitely this is a line that's going to produce a bit more straw. They're going to have pretty equivalent biomass, but you really want, so a shorter variety will produce a lot of straw, right? If you put a PGR on a variety like this, it will make it shorter, but it's going to have the same amount of biomass there, right? So it still will produce the same amount of straw. Have a look around, folks, and see what we've got differences. You can see among the commercial varieties, these canopy differences. You saw a sampling of that at the Plant Path Farm, but you can get a really good visual of those varieties that have a very upright plant architecture. Grain yield is about heads per square foot, right? It's just a matter of where they are. Where are those heads, right? In this plot, I better check again. Okay, it's an experimental, but what do you see? These heads are distributed throughout this three-dimensional space here, versus in these upright rows, all the heads are within the rows. Are the heads between the rows? Are they within the rows, right? It's still a formula, number of heads per square foot and the number of grains per spike, right? So other things to consider, right? Those are the main factors that are affected by planting density. You know, the difference between 800,000 seeds per acre and 1.8 million or 2.2 million, right? The higher seeding rates are going to result in more competition for those resources, right? The NPK. And so you're going to have fewer resources dedicated to each plant, i.e. each spike, and therefore you're going to have fewer grains per spike, right? So it gets redistributed amongst all that biomass. But a lower population tends to increase the spike fertility, and so you get more seeds per spike. So you can get grain yield a couple different ways. So these upright plant architecture, architecture, excuse me, the idea is that there's space in between these rows, right? 7.5-inch rows, they're are not plants occupying most of the space. Most of the space, there are no plants in between the rows, right? It looks like these plants are occupying those rows. Those tillers are occupying that maximum amount of space. As this plot puts on more biomass, there's less light that gets down to that part of the canopy. Yes, the flag leaf is the major producer of photosynthate, yes. But there still is photosynthesis happening at the mid-canopy, right? Open that up a little bit, there's 2% more light interception, 2% more grain yield, right? So there are different ways of getting to that grain yield. Now, the way that we would increase spikes per square foot with an upright variety is with narrower rows, right? Narrow rows always yield better. And so some varieties might be better designed for those narrow. We don't know that yet. That's kind of phase 2 of this coming up. So, but have a look around. Think about what you like in a variety and what you don't like. If something you don't like, let me know both. Actually, it helps me in the process, right? To know what works for growers or what you're interested in a variety. So I'll leave it at that and just keep the open for questions and conversation at this point. Then we can transition to Manny's thoughts in a little bit.
I think you already touched on this canopy architecture, and I'll explain a little bit more. We can go out and look at some of the plants, and I'll talk a little more about it. But yeah, the concept is the same what Eric is talking about, right? A lot of research in wheat. I think I'll maybe make a quick comment. Is if you want to push to high yield potential, Michigan has a good weather to grain fill. Generally, we get a good grain fill. So the game is getting more number of kernels per unit area, right? Yep. How do you do that? Eric already explained that, but that's what we are chasing, right? If we go to narrow rows, if we can go with these erect canopy types, we probably can have more number of kernels per unit area while maintaining their kernel weight. So that's where we hope that we can get to that next 5 bushels or so.
Absolutely. Tremendous. There's some old favorites here. Ambassador has been in the state for a while. You'll see there's quite a bit. There are really too many for me to describe each individual line. I'm going to flip some MSU lines. Here's R906. This is coming through from Michigan Crop Improvement Association. Now has a pretty good grain yield. So we've got some more. I'm going to save discussions about our MSU varieties, but we have our breeder seed lots over there, so they're a little bit more impressive than these yield plots, so I'll save that discussion for later. So here's whitetail actually, and if you guessed that Ambassador was a parent of whitetail, you'd be right. It's an Ambassador by Jupiter cross. And this line's available through Michigan Crop Improvement Association. And so we've got great straw production, competitive yield, and the Don is lower than either parent, right? So how can you cross 2 scab susceptible parents and get a scab resistant progeny? If they all have some level of resistance. Remember back up at the farm I talked about there's a degree of vulnerability. There's moderately resistant to moderately susceptible. So there's a range. And even though they're susceptible, they may have 5 genes that confer some resistance. So if Ambassador has 5 genes, if Jupiter has 5 genes, when we bring them together in a progeny, we can select all 10 of those, right? To get to incrementally move resistance higher in the progeny. So good grain yield, good straw producer. Folks have been happy with this variety the past few years, so that'd be a good one. So we got some more. There's quite a bit more. Oh, okay. Here. So I want to highlight this one. This one's in the variety trial, but it's really neat. I like this variety. It's got very upright architecture, best scab resistance of really anything that we've worked with. It's a cross between it's a Kentucky line crossed with a Purdue line, and we have the FHB1 gene in here. But this is very upright. It has very upright flag leaves and also very upright tillers. So you can see the biomass for this line is within row, but there's still some space there. So this would be a good candidate for a narrow row system. Also very high yielding under conventional with a 7.5-inch drill as well. But it's really interesting because has upright, and it looks just like ears of corn sitting right on top of there. It's got a really short peduncle versus, you can see it's a bit longer peduncle here. And so there's still photosynthate in there during the latter stages of grain fill, but just has an interesting look. So I just wanted to share that one.